go to A, and this will go to what? B1. And later it will go to B2. What is the content of R7 now? 2976. Immediate 6, 2. NBC2, 03005. Okay, this is don't care because you know this is NBC2, but you can say okay if you for the sake of things it is 3003 and it is actually what 0x3002. This will go on. NBC2. What will be the value of operand 1 here now? A 2000. What will be the operand 2, which is the immediate value, which is 2? And now we need to calculate the factor address. What will be the factor address when we add these two? Help me. 2002. Please remember, now we have R8, which is 2000. What we need to add here? 2. It will be 2002. What is the content here? 0. Okay, now this is a store instruction. We need to override this value. When? I explain it. Okay, now we have B1. What is the value of B1 in the previous cycle? 2976. 2976. Okay, this 2976. What is ALU out 1? 2002. This will go to ALU out 2. Got it? And from that ALU out 2. But this 3002 will go to where? MAR. So MAR will be 0x2002. What will go to MBR? Because this will go to MAR. B1 is here and B2. B2 goes to where? MBR. And what is the content of B2? Tell me. 2976. What is the value of LMD? No, don't care. LMD is for loading, not for storing. LMD is for loading. When we are reading, okay, now please remember, LMD when we will be reading the data from the main memory. But if you are storing the data, do we need LMD? No, it will be what? Don't care. And which value will be overwritten in memory? So 2976, this is R7 will be written into the main memory at which address? And in which clock cycle? No, clock cycle 8. Why? Because now it is in the memory stage. Can you see here? So not sorry. This value will be overwritten with the memory. And what will be the new value? Help me. 2976. In which clock cycle? 8. And clock cycle 9. When this instruction will move to the clock cycle 9, are we loading some data from the main memory or something? So what will be the right value? Don't care. Because we are not writing any register. And what will be the right number? Any question? Any question? Clear or not clear? Clear or not clear? Okay, what I am going to do now? So you can take a screenshot of all these things. I'll also post some questions. Okay, I'll also post some questions, some practice questions for you. You try to solve these questions, and if you have some questions, you can come back to me. And now please remember, we have a quiz 3 on Monday. I will not postpone it. I will not postpone it. Whatever any email you say or not, I will not postpone it. So I want you to pay attention. Any question? Should I wrap this up? Okay. Now the thing that I am solving in the next, the thing that I will generalize. I will generalize this one. Clear or not clear? Should we proceed? And the thing that I'm solving it here, this may also be the question in your midterm. Please remember, it is not there in the lecture slide. The stuff that I'm explaining it now is not there in the lecture slide. So I need your attention now. And anyone who will solve all of my questions will get 1% of bonus mark. Anyone who will solve all of my questions will get 1% of bonus mark. So I will ask 5 or 6 questions. Anyone who will solve all of my questions will get 1 bonus mark. So I need your attention here. Okay, now we have different phases of instruction execution. And I'll explain different phases one by one. Let's assume we have an instruction fetch stage. An instruction fetch stage. Now this is important now. This is very important now. An instruction fetch stage. What will be the value of IR? Anyone may be answering.
Machine code of the instruction.
Yeah. And the other
Option I.
No.
The concept of instruction.
Content of PC.
So, please remember, in instruction phase, the content of IR will be the content of the main memory. Will be pointed out by what?
PC.
Am I right or not? That's a very general thing. So basically, if we have the same example, so now we have the same example. So let's assume in this example, we have PC. The initial value of the PC in the example was, remember, 0300. And 0300 was actually the machine code of I1. The machine code of I1, it was the machine code, this was 0300. So basically, what will be the content of IR? So the content of IR will be the content of the main memory, which is pointed out by
PC.
any question. You didn't answer this simple question, sir. This is a simple question. How you can get a bonus mark? It means you are not interested in bonus mark. Okay. What will be NPC?
PC plus O.
Now, this is a very tricky thing. So basically, why I'm going to do that? E1.
Depends for.
So no, depend. What's if word addressable? No, it depends on the assumption. Again, you didn't answer my second question. What is the NPC now? NPC PC plus what?
One.
Again, if word addressable, again there are multiple assumptions. If word addressable, and if sequential instruction, please remember. So basically, okay, now I'll make it a little bit different. Because this is tricky. So if it is a sequential instruction, what is a sequential instruction? Add, subtract, multiply. This is sequential instruction. If sequential instruction, so then there is another assumption there. In a sequential instruction, if it is word addressable, what will be NPC? PC plus what? 1. Else, it means it's byte addressable. Then NPC is what?
PC plus 2.
PC plus what? Size of instruction. In LC3 there are 2 bytes. Size of instruction. In what? Bits or bytes? Bytes. Any question? Now if it's in sequential instruction. But what? If it's a branch instruction. You didn't get my point. Else, please remember, if it's a sequential instruction, that is add, so the PC should point to the next instruction. So let's assume this is my, please remember this is a little tricky. And why I'm going to explain it, this is very important. So let's assume we have 0x3001, let's assume this is sequential instruction. This is machine code of I2. And then 0x3002, which is machine code of I3, and blah blah blah. Let's assume we move to another instruction. This is I2, and this is a branch instruction. And then this is the branch target. So else, Else means it is a branch instruction. Even in the branch instruction, there are some conditions. Can anyone elaborate? Anyone can elaborate. Yes, Sangeeta. Can you elaborate? If it's a branch instruction, what should be there? If it's a branch instruction. Very good. Even in the branch condition, if it is conditional or unconditional. So even it's a branch instruction. So please remember, if, and again we have two conditions. If it's a conditional instruction, if it's a conditional instruction, and if the condition is true, condition is true, so you jump to the target. And what is that target? Please remember, the target is coming from which stage? The memory stage. So basically, the condition is true. So it means that now the target branch target. And please remember, here it is what? NPC1 or NPC2? Help me. NPC1 here. NPC2 here. NPC3. We also need, and it goes back to the PC. So basically, if the branch target is what? It is actually what? NPC3. Because this PC is, please remember now, this is now here in this example. What is the size of the instruction? 4 bytes. It's a byte decimal or word decimal? Byte decimal. Why? Because the size of the instruction is 4. If it's a word decimal, what will be here instead of 4? 1. So this is for a sequential instruction. But if it's a branch instruction, so we need to compute NPC1, NPC2, and then we check the condition. And please remember this is very important. This is coming from here. This is coming from here. This is ALU out 1. This is ALU out 1. So this is ALU out 1. This is not NPC3. This is actually ALU out 1. Because it's coming from here. And if the condition is true, so this will give me your marks. Any question? Any question? Okay, now, if the condition is false, what will happen? Again, clear? Any question? Should we proceed? Okay, which stage is this? First stage. What about the next stage? What I'm going to do now, I'm going to rub this off, and then I'm going to explain the decode stage. Should I rub this off? Now we are in the decode stage. In the instruction decode stage, we are interested in what? A, B, and then what? Immediate 16. Okay, now, what will be the content of A? Yes? Okay, so now please remember, it all depends on the type of instruction. It means that now please remember, if the instruction, okay, what will be the value of A? Please remember, if it is R type or I type. Okay, please remember, if it is R type or I type or LDR, because in LDR we also need to have an A, or STR, because in STR we also need an A. Clear or not clear? Okay, what will be the value? If all these things, what will be the value of A? Tell me. Yes, it will be the content of RS1. Am I right or not? Any question? Okay, if R type or I type or LDR or STR, is there any? You can search for any instruction. You can look into the things. There may be some instruction, but I didn't go over it. Any question? What will be the content of B? What will be the content of B? Help me. If, okay, now please remember, if R type, what will be the content of B? Help me. If it's R type or STR, please remember, now we are going for B1. Remember, B1, we have B1 here. B1. So what will be the content of B1? B1 will be the content of what? RS2. If it is R type or what? STR or what? ST. Please remember, I told you B1 and B2. Yes, Yusuf, remember? I told you B1 and B2 will be used in which case? Huh?
Store instructions.
In the store instructions. So what will be there? B1. B1 will actually be. No. Please remember, this is. No. Yes. B1 is in RS. Sorry. No. This is a little tricky. If it's R type, B1 will be RS2. And if it is else LDR or STR or ST, what will be B1? Anyone? R what? RD. Because the reason is that if it is STR, so basically A is RS1. Please remember, for STR the format will be like this. Remember in STR. Remember? So this was actually RD field. Then they are what? RS1 as immediate. And this is actually your source now. Clear or not clear? Any question? Any question? This is how it works. B1 and B1. Okay, now what about immediate field? So now we have solved for A, which is A, and then B1. What about immediate field? No. Please. Okay, so basically B1. No, okay. So basically, okay, if R or LDR or STR, A will be RS1. And if else, it is actually immediate instruction I type, if it's I type. So B1 which actually don't care. Who doesn't care? But we don't, it is. What about the immediate field? So if it is R type, immediate field will be what? Help me. Don't care. You don't need. It's R type. It's else if it's I type. Or LDR or all the in instruction with the offset. What will be the immediate value? So the immediate value will be what? The sign extension of what? Clear or not clear? Now we go to which stage? Now which stage is this? Decode. Can you run? Because now what I am going to do, now I am going to the execute stage in the next class cycle. We go to the execute stage now. We go to the execute stage. And please remember, look at the figure. This is very important. Look at the figure. Figure is very important. What will be the value of operand 1? Can you tell me? What will be the value of operand 1? Please remember there is a mux here. So here, what are you using here? NPC. So if there is an NPC, it means there is some branch instruction. Clear? So basically, if we say, if it's a sequential instruction, if there is a sequential instruction, operand 1 will be what? A. So operand 1 will be the same thing as the content of A. And if it's a branch instruction, please remember. Okay, now please remember, we have a multiplexer here. Please remember this is a multiplexer here. Now we have a multiplexer here. There is a select line of multiplexer. So the select line of the multiplexer, there are two possible values, 0 or 1. If it is 0, it is actually what? NPC1 and NPC2. If it is 0, it is NPC2. Am I right or not? Yes, and if it is 1, from where it is coming? No, from A. You got it? And it will give me what? Operand 1. So if it's a sequential instruction, so this A will be for sequential instruction. And it's a sequential instruction, so operand 1 will be A. It means that this implies that my cell mux A, I got cell mux A. Cell mux A will be 0 or 1? Tell me. 1. Else, no, it is not a sequential instruction. What will be the operand 1? Tell me. NPC2. And if it is NPC2, what will be cell mux A? Any question?
LD, is it sequential or no?
LD is not sequential. No, sorry, LD is sequential, sorry. LD, load, you're loading. Sequential.
In LD, don't we use the NPC?
NPC, we have to remember, but when we execute the LD instruction, the instruction will move to the next instruction. We are fetching the data, not the instruction. Please remember, in the branch instruction, please remember, the branch instruction will change the flow of the instruction. It will point to an instruction, but in LD we are not pointing to an instruction, we will point to the data. You are not getting my point. Let's say we have an LD instruction. This is I5. I explain it. Let's say we are using LD. LD on 5 hash offset. And then it will move to I5 and then it will move to I6. You got it? So it's a sequential instruction. But this is actually your what? Your operand 1? No, operand 1 will be, when we calculate the effector does. What is the effector does? NPC plus offset. It will point to the data.
But A in this case isn't the NPC.
Which one?
A. Instead of
A is NPC. So it doesn't matter. Doesn't matter. One minute. Yeah, you're right. If it's a sequential instruction, you're right, you're completely right. If it's a sequential instruction and not a PC related instruction, you're right. Else, if it's a branch instruction, or PC related. You're right. Very good, Ruman. Very good. Yes, you're right. Okay. What about operand 2? What about operand 2? Let's look at the mux. It's B. Then? Yes, what about B? If it is an odd type instruction, if it is not an odd type instruction, what will it be? Tell me. RS2. Very good. If it is odd type instruction, B will be RS2. If it is else if it's a store instruction, store instruction means LD, ST, STR and blah blah blah. What will it be? Very good. RD. Because we are storing the data, because it will go to B1 and B2. The same thing Yusuf you asked for that, because for store instruction we will use B1 and B2. So basically I will call this B1.
SR or RD? SR or RD? SR.
RD, this is the RD field, the first field of instruction. Because this will be used as an RD or RS. It will become as a source.
Yeah.
But actually it is the first first we have opcode, after that we have RD field. Clear? Okay, now what about B1? Else if it is immediate, the immediate field, then B1 will be what? Because there are all the possible values you need to do for all these instructions. Any question? It's done or not? Okay, please remember, this is very important. Now we have two, if you look at the mux is here, the second mux. Now we have a second mux here. So we have operand 2. Operand 2. No. B1 is already there. Yes, B1 is there. This is our type instruction. No. The operand 2. So the operand 2, yes. This is not B1. So this is operand 2. Because B1 is already been assigned. So this is actually operand 2. And please remember, this is a little tricky here, because the operand 2 will be RS2 here, the operand 2 will be RD here, and in both cases, operand 2 is already where? B1. This is B1. So we have the cell mux of B. There are two possibilities. There is 0 or it's 1. When it's 0, from where it's coming? From B1. And if it is 1, from where it's coming? From the immediate. So basically we have what? Immediate. So it will be coming from immediate 32. And this is actually the sign extension of immediate 16. Clear or not clear? Okay, now in this case, the operand 2 will be RS2 or RD. So for both of these cases, for these two cases, if this is R type instruction or R type instruction, what will be the value of cell max? Tell me. It will be 0. And what will be the value of cell max for here? Cell max B will be what? Anyone? Any question? Clear or not clear? Because this is operand 2 is the same thing in RS2, and it's actually coming from here. These two. Got it or not got it? Okay, now we have operand 1 and operand 2. This is done. But now we need to compute what? ALU out 1 or ALU out 2? ALU out 2. What will be the value of ALU out 1? Should I? Okay, now what I am going to do is I am writing here. So basically, if it is a general instruction, a computational instruction. So if it is a computational instruction, what will be ALU out 1? Help me. ALU out 1 will be what? Operand 1? Operation? Operand 2. And if it is a effective address calculation, LSAFE, effective address. LSAFE, effective address. So this is ALU out 1 will be operand 1 plus what? No, operand 2. Because the offset is already covered up here. Got it or not got it? Because if it's a normal, if it's an add instruction, the operation will be plus. If it is an AND instruction, operator will be AND. Got it or not? If it's a subtract instruction, operator will be minus. If it's a multiply instruction, operator will be static. But if you want to calculate the effective address, now in this case, if you want to calculate the effective address, because in effective address, when an effective address will be calculated, an effective address will be calculated for LDR, for STR, for LD, for ST. In that case, what we need to do? We need to add operand 1 with operand 2. Clear? No. Any question? So in which stage are we covering now? Execute. So basically now what it is? This is my AD out 1. This will be operand 1 and operand 2, and this ALU will be this operation will be defined by the opcode field. Either it will be defined by the opcode field, or either if you are calculating an effective address, so we need to add operand 1 with operand 2. Any question? Okay. Now in which stage we need to move? Next stage. What is the next stage now? The memory stage. Should I wrap this up? And please remember, some of these things may come in your midterm too. Now we are in the memory stage. Okay. In the memory stage, please remember, what will be ALU 2? This will be the same thing as what? ALU. This is ALU out 1, this is ALU out 2. Okay. In the execute stage, please remember, if you are in the execute stage, this is my B1 and this is B2. What is the value of B2 in the execute stage? Help me. B2 will be the same thing as B1. ALU out 2 will be the same thing as ALU out 1. What will be the value of MAR? Please remember, this is important now. This is very important. If it is a load or store instruction, any load or store instruction, load instruction STR, ST, SD, LD, STR. So if your load or store instruction, so load or store is LD, LDR, S and store, STR and ST. If you have a load or store instruction, what will be the value of MAR? Tell me. No. MAR. And where MAR is now stored? ALU out 1 or 2? No. ALU out 1. ALU out 1 is here. ALU out 2 is here. ALU out 2 will be, okay, so MAR will be the same thing as ALU out 1. Got it or not got it? If it is a load or store instruction, MAR will be the same thing as, otherwise, else. Are we accessing any memory? No. So MAR will be what? Got it or not got it? Again, now we go into much details. So we can say, if there is a load instruction, please remember, if it's a load instruction, what will be read write bar? 1. What will be address row? 1. And the chip select output enable write in. Remember all these things? I'm not going into much detail. If it's a load instruction. Else, if it is a store instruction, address row will be 1. Read write bar will be what? 0. And else, address row will be 0. Because we do not need a memory stage. We do not need a memory stage for add instruction, for subtract instruction, blah blah blah. Any question? Okay, now MAR. Now if it's a load or store instruction, we have MAR. Now Again, if it is a load instruction, if it's a load instruction, we are interested in what? LMD. So what will be the area of LMD? It will be the same content as what? MBR. Else, LMD will be what? Again, if it's a store instruction, now this is tricky now. If it's a store instruction, then anyone may answer. Anyone may answer. If it's a store instruction, what will happen? If it's a store instruction, anyone? Yes, Amira. If it's a store instruction, think of the store instruction. If it's a store instruction, no, it's not LMD. LMD is only used for that. LMD can load memory. We are loading the data from LMD. If it's a store instruction, yes. Please remember, if it's a store instruction, this will go to MAR. And what will go to MBR? B2. You're not getting my point again. Please remember again, why I'm going to do this. Can you see it? This will go to MAR. This way B1 and B2. So if it's a store instruction, so what will be the content of MBR? Help me. Clear or not clear? The direction will be from the microprocessor to the main memory now. Any question? Should we proceed? Okay, now we go to the write back stage. Should I rub this off now? I'm going to rub this off. And please remember, whenever you are solving, this is not easy. This is not, you need to look into the instruction. And please, if you try to solve all these things, it will also help you in understanding the LC3 instruction one by one individually, and you can better write a program if you know the complete picture, the hardware picture. Now we are in the write back stage. In the write back stage, what you are doing? What you are doing? Anyone will answer. We covered the whole thing. We did another example. We did with LDR, we did with ST. But what we are doing in the write back stage? Yes.
Changing the values of registers.
Huh?
Changing the value of the register.
Changing the value of a register. But in some cases we may change the register, but in some cases we may not change the register. Okay, so if it is an R type instruction, please remember, if again, and please remember, now this is very important. Now we have another mux. Please remember, we have mux there. Cell mux C. This is my third mux. In this cell mux, we have two values, 0 or 1. In 0, we are putting LMD here. You are not getting my point. And in the other case, what we are getting? AO1 or AO2? LU2. And this is my rack value. This is very important. If we have a load instruction, we are getting the data from LMD because we are loading the data from the memory. So can you see here? Okay, now please remember, if this is any instruction in which we are writing the register, like let's do, if we have any RD, any instruction, if there is any instruction which is modifying RD, it can be R type, it can be I type, because we are modifying RD. When you are modifying RD, so it means that a reg value will be overwritten in what? RD field of the instruction. So let's say if we have add R3, R2, R1, it means R3 will be overwritten here. If we have add R5, R3, #2, even if it is an I type instruction, R5 will be overwritten here. So it means that the RD field value of the register will be updated with the reg value. But this now reg value depending on the cell max C. Got it or not got it? So if any instruction which is modifying RD, so RD will be already in that value. But there are some instructions which are not modifying RD. Let's assume store instruction is not modifying RD. So basically, if we can also write, so if we say if it is an R type instruction, if it is an R type or I type, or if it is R type or I type or load instruction, so the value of RD will be what? The value of reg value. Now the reg value itself depends on LMD and LDO2. So we can say if it is a load instruction, if it is a load instruction, so what will be reg value? Help me. Yes. If it's a load instruction, what will be the reg value? LMD. Else, reg value will be what? LDO2. And for this case, what will be the value of cell max C? Tell me. And what will be the value of cell max C? So maybe I will also give you the cell max C in the table. This may be given in the table for all the instructions. Got it? We draw some table, remember? We draw some table, the whole thing. But in that table, I didn't put the value of cell max C, cell max C. In the table, I may change it. I may say, oh, this is my cell max A, this is my cell max B. Huh? Got it or not got it? So you need to have a bigger picture. You need to have the bigger picture. You need to have the biggest picture. So cell max C, the reg value, and in some cases, else if you say else if it is what? R type or I type or blah blah blah. You can do or type. So it's all for today. Thank you very much.